So one might say the piece de resistance of our LVMs is the ability to take snapshots. Snapshots then become a point-of-time representation of the data of a logical volume and can be read-only or read-write. The snapshot volume that we create must be created on the same volume group as the logical volume that we want to create the backup from, because really what we're doing here is we're sharing the same data. So if the data doesn't change, then we don't need to write anything through to the new snapshot volume. But if the data is changed, then we use that copy on write technology to say that we need to then write to the snapshot volume. The size of the logical volume doesn't necessarily need to be huge, but if we're using it perhaps for backup purposes, where normally we can't run the backup software if we have the service open, what we might choose to do then is create the snapshot and back up the snapshot. The snapshot volume itself then will only need to be big enough to be able to store the data changes that occur whilst the snapshot is available. So if it's only going to be there for a short amount of time, then of course we probably don't need a large size. But if we're going to keep it there perhaps for several hours and there's lots of writes going on, then it probably needs to be a little bit larger. So looking at the command here, we're going through and creating a logical volume. Remember, we shouldn't have to create the volume group because the snapshot volume should be on the same volume group as the data that we're backing up. In the example here that we're creating then the snapshot, it's a snapshot because it's marked with the -n. We set up its name to be backup, and we're backing up then the volume group data. We can then make the directory /mnt/backup, and then we can mount then the snapshot volume to the backup. From here then we can carry ahead with our backup, be it tar or whatever we're using. So we create then our backup file. At this stage then we're happy to mount the backup, and we could then go through and delete the snapshot volume. So lv remove /dev/vg1/backup. So we only created with a size of 200 meg there. We've been using the M symbol before, but if I don't put in a symbol, it defaults to megabytes. So we only set up 200 meg of space, but then that should have been sufficient for the time that the logical volume, the snapshot volume, was in place. So let's take a look at using snapshots and seeing how it works. So we're back on the command line pretty much from where we left off before, so let's clear the screen, give ourselves some nice fresh air to work with. If we go through and run the VGS command, we can see that we've got 288 meg free in volume group 1. Well, we'll stick with 200 meg, that should be more than enough. So if I go through then and lv create, -l for the size, 200, -s snapshot, -n then the name, and we'll just call it backup. And we want to create a backup of /dev/vg1/data_lv. So we've got our new volume group. If I go through and run my LVS now, we can then go through and see that we've got our data LV just at the bottom, and then we've got the backup LV, and we can see that that's 200 meg. Even though I didn't use the M, it defaults to megabytes. We can see then the attribute S is included for this, so we can see then that this is a snapshot volume. If I clear the screen, let's go through and mount /dev/vg1/data VG1, and we'll have now our backup, and we'll just put it into the MNT directory for the moment. So if I go through, let's not worry about backing up, but if I go through and look at the MNT directory, we can see then the representation of what we have within our data directory. So if I go through and take a look at /data, we're looking at the same information. If I go through and make a change to /data/services, and let's just do, say, 100 GD, so we've deleted 100 lines, and then we go through and save this. If we go through and do a word count on here, so word count -L on /data services, we can see then we've got 11,076, whereas we look at the backup file, that won't have been touched. So if we go through and look at /MNT and services, as we can now see that we've got the extra 100 lines there. So creating the snapshot is very quick. We don't actually copy any data. It's not until the data is actually changed do we have to write any additional information. So this becomes a really efficient way of giving ourselves an alternate view to the data. And now, if required, we could go through and back up the services directory because it's a representation of the data as we took it. So we're not too interested in the backup for ourselves at the moment. So if we go through and use the umount command, and let's go through and do a umount on /mount, and then our lv remove and /dev /vg1 and backup. So we can delete it. So it just gives you an idea again of some of the features that we have. We have snapshots both in our LVM systems that are managed through the traditional LVM management and also the logical volume management that are built into BTRFS. Remember, you don't need to know huge amounts of BTRFS information for the exams as they are in the moment, but I'm sure as the system matures and the exams reflect that, there will be more on both LVMs and BTRFS. For the moment, let's jump back into the slides so we can tidy up this section.